Okay,
No?
we're not graphing today.
Oh,
Okay,
I just
listen,
realized
listen.
today's day is 21/21.
Yeah, 2/1/21, yeah.
Yeah.
We are talking about graphs. We're not actually graphing. We're on page 348. We're doing 1 through
Why are you
34.
showing the picture? Oh, no,
Okay.
Leo.
Do you guys know? I can't remember.
Do you
Sit
know
down. Be quiet.
the
I
monkey
can't remember
man?
if we talked about this. Boys in the back. What does the graph y equal x squared look like? Do we know?
It's
Okay, if I plug in 0 for x, what do I get for my y value? 0 squared is 0, right? So there's the dot at 0, 0. What if I plug in 1 for x?
you get 1.
1 for the y value. What if I plug in 2 for x?
4.
2 squared is 4. What if I plug in negative 1 for x?
You get
Negative 1.
You get 1, right?
Negative 1 times negative 1 is positive 1. I forgot to graph 2, 4. Right there. Negative 1, positive 1. What if I plug in negative 2?
Positive 4.
Why do I
Positive 4.
feel like I know
So-
what you're doing?
You guys,
What's the U?
there's a symmetry here. You guys see that? It's symmetrical about the y-axis.
They're on
This shape is called a parabola. And you always get parabolas when you have a y equals x squared problem. So if it said x squared plus, whoops. If it said x squared plus 2x minus 3 or something like that, it's still a parabola, it just gets skinnier or wider or moves around the graph, or sometimes it flips upside down. But they're always parabolas. They're not exactly U's because they never go straight up. And they're not V's because they always curve. So it just goes forever. It gets steeper and steeper, but it never goes straight up. That's a parabola. All right. Somewhere between a V and a U, kind of. Let's see. Yeah. All right. Let's keep going. All right. What do you think would happen to the graph if I did that? +1.
Go up.
Think it'll go up 1?
the-
All right. Let's find out real quick.
Then steeper.
Okay. If I plug in 0 for x, what do I get for y? 0 plus 1 is 1. If I plug in 1, what do I get? 2. If I plug in 2, 5. What if I plug in negative 1? Positive 2. Some symmetry there, you guys see that? And then if I plug in negative 2, positive 5. So what's happening? 0, 1, 1, 2, 2, 5. Still a parabola. What happened to the graph though?
And that's one.
It went up 1. So when you put a +1 at the end, it goes up 1. Now some of you might have guessed that. Grace, you did. Here's where we get it wrong, where you won't guess it probably. What's going to happen if I put it directly on the x and it's being squared?
Like do 2x, right? Do 2x and plus
It's
3.
going to left to
Distributes
right.
to everything in the parentheses.
Okay,
Plus 2.
Will got close. What'd you say, Will?
It's going to move to the left to the right.
Okay, you said it's going to move left to right. So when you change the x value, it's going to affect the x. What does x do? Moves it left and right? So let's see what happens though. It might not be exactly like you think. If I plug in, let's keep doing this, I guess. If I plug in 0, what do I get?
For x?
1.
Yes, 0 for x.
So
I get 1
yeah,
squared is 1. Oh gosh, screwed up over here.
Mr. Jordan.
Go one.
Let's see. I don't,
It equals 1.
eraser's not gonna fix
Read the
the
problem.
writing
You
problem.
wish it did.
Press the, yeah, you know how to fix it?
Yeah,
I said that.
Good.
sometimes it doesn't work when I do that, so it's a waste of time. Anyway, if I plug in 0, I get 1. Okay, if I plug in 1, what do I get? 1 plus 1 is 2. 2 squared is 4.
2.
If I plug in 2, I get 2 plus 1 is 3, 9. It's going to be off my graph. If I plug in negative 1, 0. If I plug in negative 2, here's where it gets messy.
-1
Whoops.
to 1, +1. Wait.
Yeah, positive 1, Negative 2 plus 1 is negative 1, squared is positive 1.
Ooh.
Just gotta write way above it, that's all you have to do. Alright, what's happening? Negative 2, 1 is right there. Gosh, man, we got a lot worse all of a sudden. Negative
What?
1, 0, 0, 1.
Makes it a check.
No.
Is it another parabola?
1, 4. They're always parabolas when you do x squared. Okay, is it a check? No. What do you think I would get if I plugged in negative 3?
Positive.
No, it'd be positive 4 because this one over here. Because it's symmetrical, right? So it looks like that.
Mm.
Anyways, what happened to the graph when I put a plus 1 on it?
Exceeded.
Moves to the left.
Why would it go left or positive?
Okay, it goes, I know it's this is counterintuitive. It moves left 1 because everything happens 1 sooner. That's how I think of it. It moves left 1 because everything happened 1 sooner. So where it was over here, it's already started by right here, okay? So when it's directly on the x, it affects the x motion, but it does the opposite of what it looks like. So if it says plus 1, it's actually left 1.
So
If it said minus 1, right there, it's right 1. So do you guys see the difference between these two? This moves up and down like you guys guessed, some of you guessed.
Oh,
And this moves right or left, but it's the opposite of what you might guess.
damn.
This is left 1, this is left 1. So I'm gonna put the rules over here. We've done this before
Keep
actually.
it away.
You guys remember this?
Yeah.
Okay, but we didn't do it with parabolas. We did it with
Ugh.
absolute values. You guys remember those? Like
Yeah.
absolute value, and then there was like a plus 3 or something. Same rules. This was like 3 or 4 months ago, but it's the exact same rules. And in fact, it doesn't matter what function you use, it always works like this. Okay, I need to do marker. So here's the general trick. If you have, let's say, x plus 1 squared plus 2, what does the plus 1 do? Right there?
Adds
Left
2.
1 and up 2 out here. Okay? It's directly on the x, it moves the function left 1. If it's outside and not directly on the x, it just goes up or down. Alright. And then I'll do the opposite. What if it said minus 3 squared and minus 4? Right 3, down 4. Okay, those are the... If you got that, then you should have them all. Pretty much. Pretty close. That's why when I give an assignment that's 1 through 32, that's a sign, or 34, that's a sign these will go pretty quickly.
Hmm.
Wait, if it's like, where did we do one that started at the origin? Which one did we
Yeah, yeah. It was just y equals x squared. When you, well, it wasn't that. I feel like back when I did this problem, the smart board was actually working.
It was.
Anyways, yeah. A normal y equals x squared starts at the origin. So if it moves right or left, you just count from the middle to find that. What is this point right here called, do you think? I never mentioned that. Starts with a V, it's the same, yeah, it's the same thing we call the absolute value point. It's called a vertex, and it's also, it's the word you use in geometry for the corners of angles, the corners of shapes, vertex. Okay, I think we're ready. Actually, I'm going to mention one more thing. The graph of y equals x cubed, okay, not x squared, looks, I'm not going to take the time to go through it because we're on a crunch here, but looks kind of like that. Actually, it should have turned a little faster. When you plug positive numbers into x cubed, you're going to get bigger than the parabolas, right? When you plug in positive x values, you're going to get big positive numbers. If I plug in negative values to an x cubed, if I cube a negative, what do I get? Negative. So if I plug in negative x values, I get big negatives. So that's the shape it takes. And if I get like fancy and put all this other stuff
It doesn't change.
in here, well, actually the shape looks a little more like an N if I start adding other stuff. So it looks more like that. But today, I don't think we're going anything past the basic curvy thing.
Come on, 34.
That's, yeah, so 34 is the cubic function on page 348. So watch out for 34 because it's different than the other three.
I'll do another.
But the way it moves does not change. It doesn't matter if there's a squared or a cube there, that's still going to be a left one up two no matter what. Doesn't matter, doesn't change how it moves, it just changes the shape of the graph. Okay, but we're not actually drawing the shape, so we don't have to worry about that part today. Number 1. So it says, describe the translations, that means the movement, of the graph of y equals x squared or y equals x cubed. That produced the graph. Okay. So number 1, how's that one going to move from?
Up 5.
Goes up 5. So all you have to put for number 1, you guys ready? Up 5. You guys remember doing this like 3 months ago?
Yeah. I remember no
A
such
vague,
thing, but yes.
foggy memory. Somewhere in the depths of your brain.
assignments we had. Depths.
Wait, what is the?
Way down.
Number 1 is up 1. Up 5.
Because my brain is so.
The exponent changes the shape, but it does not change how the graph moves. So we don't.
What about number 2? What did you do?
Okay, number 2 is, well, what would number 2 be?
Up 4.
No?
Right,
Right 4. Okay, it doesn't matter that it's x cubed unless we actually have to graph it, then the shape would look
Mr.
different.
Jordan,
Yeah.
So if it's in parentheses and it's negative, it's going right.
If it's directly on the x, it affects the x motion. It's
Okay.
either left 1 or right 3 or something like that. Okay, number 3, what's that gonna do?
Left 7.
Left 7. Number 5,
Right, forward up 6.
right 5, up 6.
So the exponent doesn't really do anything in this section?
Yeah, not in this. Actually, it could be a fourth, a fifth, or sixth. The exponent, it could be any exponent. That would change the shape of the graph, but it doesn't change how the graph moves.
Okay.
Okay, number 7.
Right. H.
Right H,
Left and up K.
up K. Number 9 is very similar, but it's slightly different. It says state the coordinates of the vertex or point of inflection. On the x cubed graph, that point where it was turns at 0, 0 in my picture, they call that the point of inflection, where it turns and starts going the other way. Normally both of those are at 0, 0.
So
Okay.
how do you find it?
Well, just kind of the same way we did number 1. On number 9, how would the graph move?
Up 1, right 3.
Right 3, up 1. So where's the vertex? If you move right 3 and up 1, where's the vertex? If you move right 3 and up 1, where's the vertex?
3, 1.
3, 1. So the answer is 3, 1.
Okay, I thought that would be a little more complicated. Same.
Now, we did these on the absolute value 3 months ago also.
What number was that?
Number 9. So instead of putting right 3 up 1, we put the coordinates of the dot that is right 3 and up 1. So positive 3, positive 1. Okay, number 11. Where would that graph move?
One to the right.
Right. 8 left, so negative 8. And then up 6, so positive 6. So negative 8, 6. See, that was 9, 11, 13. Okay, how would 13, that's kind of a trick question. You guys, we can do it though. How do you guys think 13 would move? Up 19. So where is that? 0, 19. Yeah, there was nothing in the parentheses, so I thought that would throw you guys off. Maybe it did.
That did throw me.
But, so there is no left or right movement. There's just an up or down movement. All right, where are we at? 15. How does that one move?
7
7
0.
0.
7 to the right, so 7 0. Basically, that's where the middle of the graph is at. On the cubic functions, they call that the point of inflection. On the square functions with the parabola, they call that the vertex.
H and
Number 17, how does that move? Yeah.
right H down K, so H and negative K.
H, negative K. Right H, so positive H, and down K, so negative K.
So when they're in the parentheses, you change.
It's opposite.
Okay.
In the parentheses, it moves left to right, but opposite of what you might guess, what it seems like. Not in the parentheses, it's up and down, and it's exactly what
So
you would
yeah,
guess.
so the parentheses is the only thing that's different.
Backwards, yeah. 19. Alright, state the coordinates of the vertex, so we were just doing that. Then create a table of at least 4 more ordered pairs and graph each one. Oh, but there are graphs on this one. Missed that.
Do we have to?
Skip that
Sure.
part.
Let's do it.
There's no escape.
So, in other words, we have 5 points in total. I don't want to give you guys full graph paper for this because
But-
there's only 6 problems.
Who are they?
I'm gonna, nah, I don't think so. I'm gonna give you half pieces of paper.
Too late, I already got a full, because I take up a lot of room.
I definitely use all day words to graph.
Well, for time's sake, I guess I'll give you a whole.
Anything?
Who needs graph paper?
I mean, it's all.
Bring two in there. Alright, have you guys started yet?
No.
On, whatever we're on.
Number
19.
19. Okay, where's the vertex at?
Up 3.
Up 3. So, that's at 0, 3, right?
Yeah.
So, don't use that in your table. Don't use x equals 0 because we already got 0, 3. So what I'm going to use
Is 1,
are
2,
x values close
negative 1.
to the vertex.
Is it 1, 2, negative 1, 2?
I would plug in, well, yeah, 1 and 2 and negative 1 and 2, those would probably be the best. If you choose x values far away from the vertex, they're going to be flying up off your graph, like in the like if I chose x as 5, it would be through the roof. So, also I know that the graph is going to be going up from here, right? So I probably should have made my graph,
Can't you go?
like I should have put my x-axis down here.
Can't you go?
That way that leaves more room.
Can you flip them or no? Is that? Can you like?
You can, but they're not, none of these, if you have a negative in front of your x squared, it's going to be upside down. But none of these have negatives, so we're not going to have any upside down parabolas today. There's a line. Okay, so 0, 3 was the vertex, right?
Yeah.
Okay, and
Which one's your?
this is my x-axis, this one's nothing, just another
A special line.
special. Alright, so I'm going to plug in x as 1, yeah, 1, 2, negative 1, negative 2, those are good x values. And if I plug in 1,
So do you only need 4, or do you need?
you need 4 besides the vertex, so 5 in total.
Mhm.
If I plug in 1, what do I get? 1 squared plus 3 is 4. If I plug in 2, what do I get? 2 squared plus 3.
I thought this was
7.
17.
If I plug in negative 1 squared plus 3, 4. And if I plug in negative 2 squared plus 3, 7. Okay, that is only going to happen if you choose x and y values around the vertex. Because it should be symmetrical, same on left and right. So if you're choosing x and values that are the same distance on left and right, they will be the same. So 1, 4 is right there. 2, 7, 2, 3, 4, 5, 6, 7 is right there. So you can kind of just match it on the other side with that.
How'd you
Yeah,
get 1,
that's a
4?
caliber Gabaga.
Huh?
Oh, from the bottom line.
Right.
I moved the bottom line down, the x-axis.
Did I ask?
You coloring that one.
Okay, I will be looking for that table
So bad.
that I made right there, 1427, negative 14, negative 27, that stuff.
He will watch it.
You're not starting from 3, you're starting like a normal graph. You're not starting from
Yeah, you gotta start counting from the origin at 0, 0. So 1, 4 is like right here.
And should there be arrows at the end of it, cause it can keep going?
Yeah, it goes forever. You guys heard the phrase exponential growth?
So that
Can
has,
it,
Nope.
for
there has
most
to be
of them,
5 in each
It's
thing?
where the value keeps increasing, going up at a faster
so
and
for
faster
most
rate.
of them, can we use the same numbers besides maybe like 24?
That only works if your vertex is like straight up or down. If it's left or right,
Oh, and
then you have to choose
the parentheses.
x values that are left or right.
Alright.
Anyway, we'll do another one. So 21.
Well, we have 2 more.
Yeah, we got 2 more. What's the graph on 21? Where's it gonna move to? No.
Oh.
I think that's left.
Left.
Left
Left
two.
2. Did we forget already? Left
Yes.
2.
Maybe?
What shape is this gonna take?
It's gonna be a.
Okay. I don't know how to describe it, but it's not a parabola, right? Not
Whoa.
okay. But even if we forget the shape, we're still plugging in numbers, so it doesn't matter. What's a good x value to plug in? This x value is at -2, so what's a good x value to plug in?
Negative 1.
-1 and 0, and -3 and -4. This shape is not symmetrical, so it's going to be different than the other because it's x cubed. So if I plug in -1, I'm looking at 21. -1 plus 2 is 1, and 1 cubed is 1. 1 times 1 times 1. If I plug in 0, 0 plus 2 is 2. 2 cubed is
6. 9. 27.
2 times 2 times 2 is
8.
8. If I plug in -3, -3 plus 2 is -1. -1 cubed. -1 times -1 times -1,
It's just negative 1.
-1. Okay, they're not symmetrical, but they are related. You see that? And if I plug in -4 plus 2 is -2 cubed. -2 cubed. Not 3 cubed.
Negative 8.
-8. -2 times -2 is 4 times -2 is -8. Okay, so now I'm going to graph. -1, 1 is right there. 0, 8 is a little bit off my graph. -3, -1 right there. -4, -8, a little bit off my graph.
You're going so fast.
I'm just graphing the dots. You guys know how to do that.
I do.
Not.
Maybe.
And then connect the dots. Here's what it should look like. It gets flat right there actually, and then it's really steep.
Like a slide.
Oh, isn't it just?
If that was a slide, you'd probably die.
No.
Well,
Because you would hit the ramp right here and then.
Fall into the
Well,
water.
we-
Expert.
Maybe one of those water slides, you know.
You said it was a water slide.
it's a death slide. Apparently.
It's a death slide. Alright,
It's coming for you.
it's 21. That's what a basic cubic function looks like. Okay, 23, one more of these for me.
What? For you?
For
Well, I
me.
mean, you have to grade them.
Yeah, I gotta grade them. So where is the so 23 is another x squared function, so it's gonna have a
Right 4.
parabola. Right 4 and
Up 1.
up 1. There's the vertex. It's gonna be going up from there, so you might, I think we'll be alright. Just leave that on. So what would be some good x values to plug in? No, this x value of the vertex is at positive 4. So we probably want positive 5, 6, and 3, 2. Those are pretty close. 5, 6, 3, 2. You can plug in anything, but once you plug in numbers far away from the vertex, you're going to get really big y values. So we don't want to do that. So we can actually graph it. If I plug in 5, okay, I'm looking at 23. 5 minus 4 is 1. 1 squared is 1. Plus 1 is 2. So 5, 2. If I plug in 6, 6 minus 4, 2 squared, 4 plus 1. If I plug in 3, 3 minus 4 squared, plus 1, 2. So we're back to symmetrical again, right? If I plug in 2, 2 minus 4, negative 2 squared, 4 plus 1.
5.
So 5,
5,
2, 6, 5, 3, 2, 2, 5. Your picture should always look something like that if you're doing it right on the x squared problems.
Isn't it just adorable? Anyway.
Okay. 25. We're back to pretty quick. These go pretty quick again. How do I write a function? Okay, we're using the y equals x squared function. How do I make the function go 10 to the right?
Minus 10.
Minus 10, where? Outside or inside parentheses?
Inside.
Inside. That moves it 10 to the right. Don't forget the little square thing on it.
Yeah.
Yes.
Well, if you want it right, you don't.
Oh, the little 2.
That was hilarious.
Alright, that was 25. 27. How do we make it go left 3? We'll start with that.
Minus. Oh, we're doing
Plus
1 thing.
Plus 3 in the parentheses. How do I make it go down
Minus
12?
Minus
Minus 12.
12. We still need the. Why do we need the 2?
Because we're doing a quadratic function.
To make it right.
The x squared is what makes it a parabola thing. We're doing, quadratics. If I didn't add the 2, it would just be a line. Alright. 29, how do I make it go right 2? Minus 2 in the parentheses. How do I make it go up 1? Plus 1. $31, it's the same thing, same kind of answer, but they're not, all they're giving us is the picture.
So it would just be x squared plus 2
Okay, yeah, that graph is going up 2, how do I make it go up 2?
plus 2
Plus 2 in parentheses or outside?
outside.
Outside. There is no right or left, so there is no parentheses.
Oh, 31. So would this just be x squared minus 2? No,
Okay,
it wouldn't.
33, let's start with, the parentheses is left to right, right? So, how far to the right is that vertex? 2 to the right. How do I make the graph move 2 to the right?
Minus 2.
Minus 2. Okay, also the graph is how far down?
Down 2.
Down 2. How do I make the graph move down 2?
Minus 2.
Minus 2.
Evens.
Okay, what's different about 34?
It's cubed.
It's a cubic function,
Or you can
so you need to put a little 3 on your parentheses, not a 2.
Okay.
Alright, we'll take that
Just
off.
rush
Yeah.
What did you say?
In 34, it is a cubic function, so you need to put a little 3 on your parentheses when you do that one. Alright.